This section will try to explain free energy graphs. Not always very popular with students, often find difficulties with these, perhaps because it looks a little bit mathsy. So hopefully this will explain it. Now, what we want to do is take the Gibbs free expression and turn it into a straight line graph. So this is back to a bit of GCSE maths. So where we've got the y equals mx plus c. Hopefully you remember that. Let's try and match these two expressions together. So we can probably see that the combination, the m with the x, is going to be the t with the delta s, or the minus delta s, which means that on its own is delta h, and this is going to be our c component. And as you can see in the information there, we're plotting delta G against temperature, delta G being the y-axis and temperature as the x-axis. So this leaves delta S. Remember, we've got the minus sign in there as our m, which will be our gradient. Let's have a look at this graph, free energy graph for a random reaction. It looks fairly complicated to start with. Let's break it down into its individual components. So first up, we can see that the y-axis is values of delta G, and the x-axis is temperature. We saw just before that the y-intercept is delta H, and that the gradient is minus delta S. Anything else to pick out from this graph? Well, we've got positive and negative values of delta G, so these values are all negative, so this is where the reaction is feasible, and anything above this line, then the reaction is not working. This is also worth looking. So this is the temperature at which the reaction becomes feasible. So any temperature above what's looking to be somewhere around about 380. So any temperature above 380 Kelvin, delta G is negative, and so at these points the reaction is feasible. Now the question is asking us to work out delta S for this reaction, and that means that we need to get the gradient. So what I did with this graph is basically take that whole triangle that you can see there, which goes from plus 50 down to minus 40 in terms of delta G values. So that was 90 kilojoules per mole, and it goes all the way from 0 across to 700. So I worked out the gradient based on that. But remember, when we look at the points, our difference in y values, I'm going from minus 40 to 50, and in x values from 700 to 0, which means I get minus 90 over 700. And remember, that is minus delta S, So minus delta S is minus 0.129, which means that delta S will be 0.129. This will then need converting into joules per mole. So currently we're in kilojoules per mole because of the values of delta G, and so we just want to times that through by 1,000, and that means that delta S is 129 plus 129 joules per Kelvin per mole.